Hello everyone, welcome back to my channel. This is the Civil Lectures channel where you can actually get videos on problems relating to civil engineering. Okay, to our next today's video, we'll be talking about how to calculate our shear force and our bending moment diagram. On the last video, we were able to derive our moments of this problem at support A as minus 55.6, support B as minus 73.84, and support C as minus 263.03 kilonewton per meter. So but today we are going to be drawing the shear force and the bending moment diagrams. And drawing the shear force and bending moment diagrams, we have to split our beams into sections. I'm going to be considering from span A to B. Considering span A to B, I'll draw out a section of it. Here I have my supports as this, and then I have a fixed support here. Because it's a fixed support, it's going to be carrying two moments. It's going to be carrying two reactions, and then it will carry a moment. And moment at A, as we calculated before, was 55.6. Moment at B, as we calculated before, was 173.84. And then there's a uniformly distributed load of 50 kilonewton per meter. Then let me call here my reaction at A, and here my reaction at B left. Then this is my HA, which should definitely be 0. And then the spanning from here to here was, from our question, it is 6 meters. Now, the normal thing we do, this is now a simply supported beam, and for a simply supported beam, we can apply equilibrium condition for it. Applying equilibrium conditions, I have there that my summation of vertical forces is equal to 0. And what are the vertical forces here? We have our arrow A and our arrow B. So that means that my arrow A plus arrow B left will be equal to 50 times 6, converting it to a load, or my arrow A plus my arrow B left, then minus 50 times 6, which everything has to be equal to 0. And this means that my arrow A plus arrow B left minus 50 times 6, 300, minus 300 equal to 0. I can call this my equation 1. And then, since I have an unknown as arrow A and another unknown as arrow B left, then I need to take moment at any of the sides. And taking moment at any of the sides, taking moment at B, let's take our moment at B. Remember, this is our B and this is our A. So taking moment at B, remember that summation of all moments has to be equal to 0. Please, if you have not subscribed to this channel, do where to subscribe. Then let's continue. Summation of moments is equal to 0. So if summation of moments is equal to 0 and I'm taking my moments here, that means my moment at B is equal to 0. Then every other force will move towards B. Arrow A will move towards B, 50 kilonewton will move towards B, and then this moment will still move towards B. So the first thing I'm moving here is arrow A times 6. And it's moving in the clockwise direction, so it's positive. Then the next one is 50, moving in an anti-clockwise direction, so this is 50 times 6 squared all over 2. Then the moment at arrow A is moving anti-clockwise to B. It is moving, look at the direction of the force, it is moving anti-clockwise to B. So this is minus 55.6. and this is moving clockwise to B, which is plus 173.84. So I have here that 6 arrow A minus 50 times 6 squared divided by 2 would be 900 minus 55.6 plus 173.84, everything equal to 0. So my 6 ROA is minus 900 minus 55.6 plus 173.84. That would give me equal to, if that would give me minus 781.76, but moving it to the other side of the equation, it will turn to positive 781.76. So that means that my ROA would be equal to 130.3 kilonewton. Then the same way, I'm going to be taking my moment at A, so I can find my B, my reaction at B. Taking moment at A, I'll have that summation of all moments is equal to 0. And summation of all moments equal to 0, that means that my arrow B moving in an anti-clockwise to A, that is 6 times arrow B is minus 6 times minus arrow B. Then the 50 kilonewton is moving in the clockwise direction, that is plus 50 times 6 squared all over 2. Then at A, the moment at B is moving in a clockwise direction, that is plus 173.84. Then at A, the moment at A is moving in an anti-clockwise way, that is minus 55.6. So this is 6 RB plus 3 plus 900 plus 173.84 minus 55.6. So this is 6 RB, that is 900 plus 173.84 minus 55.6, and that will give me this is minus 6 RB, so this is minus, and this crossing over to the other side will turn to minus 1018.24. So my RB would be equal to, divided by 6, so this would be equal to 1018.24 divided by 6, that is 169.7 kilonewton. So to confirm if our answer is right, that means I have to sum my ROA plus ROB and then subtract it with 300 to know if my answer would be 0. So doing that, I have that 169.7 plus 130.3 would be equal to 300. If you can see very well from the calculator, 300, then 300 minus 300 would definitely give our answer as 0. That means that our reaction at A is 130.3 and our reaction at B 169.7. So the next thing I have to do here is to calculate my maximum bending moment at span A to B, and doing that I need to know the span at which the maximum bending moment will be occurring. Doing that, I have to just take it as if I'm taking my shear force. Taking my shear force, let me call here to be X. And then at X is where I'm expecting the maximum bending moment to occur. So doing that, I have to take my shear force at X. Shear force at X, let me call here my K, point K. So taking my shear force there, I'm going to have it that ROA is moving upward, and the value of ROA is 130.3 kilonewton. Then 50 minus 50 times X, that is converting this to a point load, that is 50 times X. I'm assuming that this is a span X that I don't know the value, so I need to find the value of X. And doing that, I'm taking the shear force here, ROA is moving upward, then minus converting this 50 to a point load will be 50 times X. So that was why I had my 50 times X here. So this is minus 50 minus 50x would be equal to minus 130.3. So that my x would now be 130.3 divided by 50. So my x value is 130.3 divided by 50. That is 2.6 2.6 meters. So at the span of 2.6 meters, that is where I'm going to be experiencing my maximum bending moment. So from this, I can now calculate my maximum bending moment at K. Moment at K. Moment at this K would then be RA times, remember our X is now 2.6, so RA times 2.6 and 50 times 2.6, that is, my ROA is 130.3 times 2.6, then minus 50 times 2.6 squared over 2. Then there is another moment acting here. So this moment moving to this would be minus 55.6. So that means that my maximum bending moment at K, my moment at K, 130.3 times 2.6, that is 338.78 minus 50 times 2.6 squared divided by 2, that is minus 169 minus 55.6, and this will have to give me as 338.78 minus 169.55.6, 169 minus 55.6. So my maximum bending moment is 114.2 kilonewton meter. So I am done with this palm. So that means that my maximum bending moment at K will be 114.2, my reaction at A will be 130.3, my reaction at B 169.7. Then the next thing for me to do here is to pick span B to C, and after that we can draw our bending moment diagram and our shear force diagrams. So okay, then drawing out the splitting out span B to C, I'm going to be having this diagram with a point load at this and the moment at B are still 173. If you can recall from the last one we did, we had moment at B to be 173. That means that there will be a moment acting here 173 moving anti-clockwise, and then there will be a moment still moving clockwise as 173. So that is the span B is carrying two moments, unlike the span C and the span A. So from there I was able to split out and I was able to draw the span B to C. Now we are going to be resolving and we are going to be finding the shear force and the bending moments there. And applying equilibrium condition, I'm going to sum that ROB right will be plus ROC will be equal to 50, or ROB right plus ROC minus 50 kilonewton will be equal to 0. Everything has to be equal to 0. So now I can now take my moment at any of the sides. Taking moment at C. If I take moment at C, I have the summation of moment is equal to 0. And taking moment at C, that means that this is going to, ROB right will move towards C, and then 50 will move towards C. And when I'm doing that, ROB right is moving in the clockwise direction. That is ROB right times 6. This distance from B to C is 6. Then 50 moving anti-clockwise will turn to negative 50 times 3. Then that is all about the forces. Then I have a moment moving anti-clockwise to C, which is minus 173.84, and I have another moment moving clockwise to C, which is plus 263.03. So this is 6 ROB right minus 150 minus 173.84 plus 263.03. So my 6 BR right will be equal to, that is minus 150 minus 173.84 plus 263.03. So my answer is 60.81, moving it to the other side of the equation. So this divided by 6 would give me that my ROB right will be equal to 10.14 kilonewton. The same way, I'm going to be taking my moment at B. Taking my moment at B, I'll know that summation of moments is equal to 0. And if summation of moments is equal to 0, that means that I'm taking my moment at B, remember? So Arusi will move to this and 50 will move to this. So Arusi moving to this in an anti-clockwise direction will turn to minus Arusi times 6. The distance from C to B is 6. Then 50 moving to this will be plus 50 times 3. Then there's a moment at B which is anti-clockwise to it, that is minus 173.84, and then there's a moment moving to C which is moving in a clockwise direction, plus 263.03. So this is minus 6 RC plus 150 minus 173.84 plus 263.03. So minus 6 RC would be equal to is 150 minus 173.84 plus 263.03. That is 239.19. Moving it to the other side will turn to negative 239.19, and dividing it by minus 6, I'm going to be having that my RC will be equal to 39.9 kilonewton. So checking if my reactions are correct, that is 10.14 plus 39.9 would give me 50. So my reaction at B right will be equal to this, and my reaction at C would be equal to, so that summation of all the vertical forces here would still give me equal to 0. Then I'm done with finding my reactions. I need to find my maximum bending moment at this span. Already this is a point load, so I should know that my maximum bending moment will be happening at where the point load is. Definitely if this beam should be loaded, then this beam is going to bend towards the direction of this load here. So I need to find my moment at K, and my moment at K will turn to RB times this, and then with the moment 173.84. So the value of RB right is 10.14 times the distance of B to K is 3, and it's moving in the clockwise direction, remember. Then I now have the next moment I'm having here is the moment happening at B, and that is happening in an anti-clockwise direction. So I'm going to be using a negative sign, minus 173.84. So this will be equal to 10.14 times 3 minus 173.84. That will be 143.4 kilonewton. So I've been able to find my maximum bending moment as this, and then my reactions as this. So the next thing we are going to be doing now is to draw our bending moment and our shear force diagrams. So from our calculation, we've been able to find our reaction at A as 130.3, and reaction at B left as 169, reaction at B right at 10.19, and reaction at C as 39.9. Then the moment at K, the maximum moment at this and the maximum moment at this. Then before now, we calculated our moment at A as equal to minus 55.6, moment at B as minus 173.84, and moment at C as equal to minus 263.03 kilonewton meter, and kilonewton meter. So for me to draw my shear force diagram, I have that my moment at my shear force diagram, my reaction at A is 130.3. So I can just shift my hands up to 130.3, positive 130.3. Then my reaction at B left, my reaction at B left to be at the downside of my graph, and then my reaction at B right to be at the upside of my graph. So that means that my reaction at B left is 169.7. So 169.7, and then my reaction at B right, that is 10.14. and then my reaction at C as 39.9, and this is 39.9. So if I'm joining this, because it is a UDL, it's going to be forming a slant shape from here to join to it, and then move up to it, and then I'm having a point load here, so it's going to be straight to move straight to this, where I will meet a 50 kilonewton, and 50 kilonewton moving downwards, 50 kilonewton moving downward, that is, I'm having 10.14 here, so that means that 50 minus 10.14 will give me 39.9. so the 50 kilonewton load here has been able to push it down to 39.9, and then it will get back to 0. So I've been able to draw the shear force diagram, where we can just shade our diagrams. Here we call this our positive values, our negative value, we call this our positive values, and this is our positive values, we call this our negative values, we call this our positive side, and this is the negative side, and this is the shear force of my diagram. Now I'm moving to drawing the bending moments diagram. To draw the bending moments diagrams, where the upside will be our negative side, and then the downside will be our positive side. Then at moment at A, I am having 55.6. Moment at B, I am having 173.8, and then moment at C, I am having 263.03. Then the maximum bending moment at span A to B was 114.2, while the maximum bending moment at span B to C was minus 143.4. So I can join this value. Since it is a UDL, it's going to form a parabolic shape to B. Sorry for that. Going to form a parabolic shape to B, and then I met a point load here. This is the maximum, so it's going to slant to this, and then slant to this other side, and moves back to 0. So I can shade my values, and call here my negative side. Right here becomes my positive values. So at this, we've come to the end of this problem. This is the shear force, and this is the bending moment. Thank you very much for watching, and please subscribe to my channel.